Hey guys, so before we get right into the question, we must first cover some very important objectives that will be discussed for the question. So we'll be learning how to balance equation, calculating mole, finding the mole ratio, identifying the limiting reagent and excess reagent, calculating the theoretical mass, and finding the percentage yield. So for the first question, it asks, nitrobenzene C6H5NO2 is used in small quantities as a flavoring agent or in perfumes, but can be toxic in large amounts. It is produced by the reaction of benzene C6H6 with nitric acid. So, from the question, we can identify that the reactant side or the reacting products are the benzene and nitric acid. How do you know this? Well, you can know this because it says it is produced by the reaction. So what is produced is actually the nitrobenzene from this reaction here. Okay, so now we'll be writing out the compounds on the reactant side, which is C6H6. Don't forget your state symbol, which is aqueous, AQ. Aqueous is represented by the symbol of AQ, plus H NO3 which gives us C6H5 NO2 plus H2O, water. Okay, so from this reaction, before we move on, we need to first add in the state symbols, as I mentioned before, which is aqueous, which represents by AQ, and this again, which is represented by AQ. And last, water is in a state symbol of liquid. Okay. Okay, so let me just write this a little bit better here. So it should be a subscript, which is 5. Okay, so to tell if this chemical equation is balanced, we must first check how many of the atoms are present on each side. So for carbon, we see that we have 6 carbons on the left hand side of the reactant side, 7 hydrogen, because 6 plus 1 gives you 7, 3 oxygen, and 1 nitrogen. And on the right hand side, the product side, we see that we have 6 carbon. So there's 6 carbon on the reactant and the product side. So we know that the carbon is balanced. And there are 5 plus 2, which is 7. Again, so there are 7 hydrogen on the reactant and product side. And there are 2 plus 1, which is 3. So there are 3 oxygen on the reactant side and product side. So they are balanced. And 1 nitrogen on the product side. So as we can see here, we have 6 carbon, 7 hydrogen on both sides, oxygen on both sides, nitrogen on both sides. So from this reaction, we can see and tell that this equation is balanced. Because why? All of the atoms on both sides are equal. And right here, this type of reaction is known as a nitration of benzene. And this is basically the balance equation of what I just illustrated up above. And very important thing to note is that for this type of condition, we need concentrated sulfuric acid. For the second part of the question, it asks us, identify the limited reagent and the theoretical mass of the nitrobenzene produced in the reaction of 27.5 gram of nitric acid with 75 gram of benzene. So they gave us the mass of nitric acid and also the mass of benzene. And also I have said I'm going to write the equation because this is going to be necessary in the calculations below as we go forward. So given the mass of benzene, which is 75.0 gram, and the molar mass, which is 78.114 gram per mole, which I will show you how I derive to this going forward. So whenever we're given the mass and the molar mass, we can therefore find the moles of the compound, in this case benzene. So moles is equal to mass divided by molar mass. So given that mass of benzene is equal to 75.0 gram divided by the molar mass, to find this we have to first say we have six atoms of carbon, and carbon has an atomic mass unit of 12.011 AMU plus 6 atoms of hydrogen times its AMU, which is 1.008. So 75.0 gram divided by 72.066 plus 6.048. So now we are going to add the molar masses of carbon and hydrogen together to get the total molar mass of benzene. 75.0 gram divided by 78.114 gram per mole. So we can now see how we got this. So we basically added the 72.066 plus 6.048 and we got 78.1114 gram per mole. And from this, let us take out our calculators and we can now see that the moles of benzene is calculated to be 0.960 moles. Now, whenever we are doing this type of calculation, there's something very important that we should pay keynote attention to, and which is the significant rules. So for this case, we are doing the significant rule for multiplication and division. So for this type of problem, whenever you're doing multiplication and division sig-fig rule, it states that it's the number with the least number of significant figures. So from this question, we can see that the mass has a significant figure of 3 and the molar mass has a significant figure of 5. So for our answer, it should be up to 3 significant figures. For the next question, for part 2 of this question, we can see that we are given the mass and the molar mass of nitric acid, which is, so we're now going to apply the same rule for the nitric acid. So we're going to find the number of moles of nitric acid, which is moles again is equal to mass divided by molar mass. And of course, same procedure applied here. 27.5 gram divided by nitric acid, which is 1.008 plus nitrogen, which is 14.007 plus oxygen. Since in nitric acid there is 3 hydrogen present, so we have to say 3 times the atomic mass unit of oxygen, which is 15.99 AMU. So we're now moving on. 27.5 gram divided by, when we add up all of this, we should get 63.01 gram per mole. So for our answer, it should give us 0.436 moles of nitric acid. And remember guys, very important is that we obey the significant rule of multiplication and division. So for this right here, we can see that there is 3 significant figures for the mass, and there is 1, 2, 3, 4, 5 significant figures for the molar mass. So this is how we get our answer to 3 significant figures for the nitric acid. Now that we have found the number of moles for the nitric acid and benzene, we must first identify what is the limited reagent. But before we can do that, we must first understand by definition what is a limited reagent and what is an excess reagent. So a limited reagent is a reactant that is completely used up in a chemical reaction. And an excess reagent is a reactant that is not completely used up in a chemical reaction. Okay, so to identify the limited reagent in this question, we have to see which one, whether it be the nitric acid or the benzene compound, which one of them has the least number of moles. And the least number of moles will tell us which of the compound is the limited reagent. So, as we can see, benzene has 0.960 moles and nitric acid has 0.436 moles. So, therefore, from this question, we can say since benzene has more moles present, it is therefore the excess reagent, and since nitric acid has the least number of moles present, it is the limiting reagent. And to further simplify it, as I said, limited reagent is the 0.436 moles of nitric acid, and the excess reagent is 0.960 moles of benzene. So now that we have identified the limited reagent, we must first now next identify the theoretical mass. And to get the theoretical mass, we must first understand what is it that we were given and solve it from there on out. So Let me just clear my whiteboard here and let's do that. So we have the mass of nitrobenzene, and we have the mass of nitrobenzene, which is equal to 0.436 moles times 123.11 gram per mole of the nitrobenzene. So this is the molar mass of the nitrobenzene, and this is the moles of nitrobenzene. And when we do this calculation, 0.436 times 123.11 gram, we get an answer of, let's work it out, 53.7 grams of nitrobenzene. So, as I said, it's always very important to obey the significant rules whenever you're doing these type of questions. So, as we can see, there are 3 significant figures for the moles, and there is 1, 2, 3, 4, 5 significant figures for the molar mass. So, therefore, the one with the least number of significant figures is what we give the answer, or the mass of nitrobenzene in, which is 57.7, which is 3 significant figures. So now that we have found the theoretical mass of nitrobenzene, we'll now move on to the next part of the question, which is to calculate the percent yield if 48.2 grams of nitrobenzene is obtained from the reaction. So we must first ask ourselves before we start doing anything, what is percent yield? By definition, percent yield is the actual yield divided by the theoretical yield, open and close bracket, times 100. So, as the question has given us, we were given the actual yield, and from the last question, we were given the theoretical yield. Okay, so as you can see right here, the actual yield is 48.2 gram, and the theoretical yield is 53.7 gram. Now, to solve this question, we will now have to say the actual yield from the definition, 48.2 gram divided by 53.7 gram, open and close bracket, times 100. So now when we do that calculation, we should get an answer of, so the equal to 89.8% yield of nitrobenzene from the reaction. And that is how you would have found the percent yield of nitrobenzene from the reaction. And very important, guys, before I leave, or before I end my presentation on this question, always obey the significant rules. So for division and multiplication, it's the one with the least number of significant figures. So for this question, we can see that both the actual and theoretical has 3 significant figures. So our answer is given in 3 significant figures. And that concludes my solving of all the questions A, B, and C. And this is where my presentation will end. Do not forget to like, share, and subscribe, and stay tuned for more videos like these on Chem with Zach. Peace out.